The Sun is the center of our solar system, which means that our solar system is heliocentric. In essence, this explains that the planets of our solar system orbit around the Sun, not the Earth. And also explains that one revolution of the Earth around the Sun is considered one calendar year to us. Our Sun is the closest star to Earth, and yet it is still 93 million miles away, which is roughly the distance of New York City to Hong Kong multiplied 156 times. The Sun is massive, and that means we could fit 1 million Earths inside our Sun. And it takes light from the Sun 8.3 minutes just to reach Earth. The Earth as we know it today would not exist without the Sun. It provides us with light, warmth, and is needed to grow plants, which gives us food and oxygen to breathe. Its sunlight also allows our bodies to produce vitamin D, which makes us happy and healthy. However, the Sun also radiates harmful UV rays, which are also called ultraviolet rays, into our Earth. It is important for us to remember that despite the benefits of our Sun, there are also dangerous aspects of it. For instance, we need to wear sunscreen when we are out in the sun for a long time because UV rays can cause our skin to burn, which can cause skin damage. This damage could lead to skin cancer called melanoma. We also need to protect our eyes from UV rays with UV-protected sunglasses because if we look directly at the sun for too long, eye damage, specifically retinal damage, can occur. Light will continue to travel until it hits an object, or what's known as an opaque object, which is something where no light can travel through it and cannot be seen through, which will create a very dark shadow. Something that is transparent allows all light to pass through it and can be seen through, and therefore no shadow will occur. Something that is translucent allows some light through it, but cannot be seen through fully. Therefore, it will create a faint shadow. The closer an object gets to a light source, the larger the shadow is because it's blocking more of the light. Shadows can also be used to tell what time of day it is. Our Earth rotates on its axis once per day, meaning that every 24 hours our Earth has spun around itself. By doing this, it creates night and day, because when it is day where you are, that side of the Earth is facing the sun, and at night it has turned away from it. Which means throughout the day our sun is in different positions in our sky, creating different kinds of shadows. For instance, when the sun rises and sets, it is low in the sky and produces longer shadows because it is hitting the opaque object at an angle. The lower the sun, the more significant the angle and the longer the shadow. At noon, the sun is at its highest point in the sky and hits an opaque object directly above with no angle, so the shadow is created directly below the object and is generally not seen. Before clocks were created, our ancestors used what's called a sundial to tell what time it is. They used the position of the sun in the sky and what shadows the sun created to do so.
You can easily make a sundial right from home using the following steps. The materials are all very easy to find and you probably already have them at home. You will need crayons, markers, or any other colored utensil, a paper plate, a sharpened pencil, a ruler, and a straight plastic straw. You'll want to start preparing the plate around 30 minutes before noon on a sunny, cloudless day. Use a marker to write the number 12 at the top edge of the plate. Take your sharpened pencil and push through the center of the paper plate, then remove the pencil so that you're left with a hole in the center. You might have to do some wiggling. You'll eventually put your paper straw into the hole. Use your ruler to draw a straight line from the 12 at the top of the plate to the hole in the center of the plate. You'll now have to find the closest celestial pole using a compass. Your straw should point towards the closest pole, which is parallel to the Earth's own axis. If you live in the northern hemisphere, the closest pole is the North Pole, so set the straw slightly pointing north. Place the straw into the hole in the paper plate, slightly tilted towards the closest pole, and bring the plate outside shortly before noon. Place it on the ground where it will get full sun exposure all day. Return to the plate 1 hour later. At 1 p.m., go back to the plate and check the position of the straw shadow. Write the number 1 at the very edge of the plate where you see the shadow ending. Continue this process every hour until you get back to 12. You'll notice that throughout the day the shadow moves clockwise.